This is section 1.5. So we have all these problems to do. Page 66, all the way up to problem 72. So let me show that to you for those of you who don't have the book and aren't getting it. 3, 4, 5, 6, 7, 8. That shows you up to maybe 17-ish, 18, 19. This is on page 67. In the very bottom there. To kind of turn the book sideways to get it all in. Some work with logs. Rough sketch of the function. Solving equations. Problems at the end. 63, 64. And up to 72, I think was the last one. Okay. All right, so first we have 3 through 12 all. Okay, 3 and 4. First we have to talk about a one-to-one function. Okay, just a function. A function has a property that for any x, there's a unique y value. So 3 and 4 are both functions. In other words, you don't see 1 showing up twice on the list or 2 showing up twice. 1, 2, 3, 4, 5, 6. There's never a 1, 2, 3, 3, 5, 6, or whatever. That would not be a function. For a one-to-one function, you ask, is there a repetition of any y value? If there's a repetition of y, we do not have a one-to-one function. Otherwise, we do. So number 3, I see a 2.0 here and a 2.0 here. So that means number 3 is not a one-to-one function. Number 4, none of the y values, and by the way, it says f of x, but that means y. And none of them are repeated. So number 4 is a one-to-one function. Okay, a one-to-one function will pass the horizontal line test. So you've heard of the vertical line test, no doubt. We have a horizontal line test for one-to-one functions. Horizontal line test. A function is one-to-one if and only if no horizontal line intersects the graph more than once. Okay, so y equals x cubed is one-to-one. Y equals x squared is not one-to-one. It touches the graph in 2 points. Okay, one-to-one functions have something called an inverse function. Okay, this is on the bottom of page 56. Okay, we write it f inverse, f with a -1, f inverse of y equals x means the same thing as f of x equals y. You basically switch around the x and the y. Okay, the domain of one becomes the range of the other. You just switch domain and range. Okay. And then you have the cancellation equations. If you ever apply a function and its inverse, they cancel out. So equation 4, f inverse of f of x equals x for every x in the domain A, and f inverse of x equals x for every x in B. Set B. Okay, how do you find an inverse function? Right, y equals f of x. Okay, we're going to switch around the x and y and then try to resolve for y. And I'll be showing you how to do that. Okay, some properties of logs. We call logs on page 59. Okay, log base b of x equals y means the same thing as b to the y equals x. Number 7, log base b of b to the x equals x, and b raised to the log base b of x equals x. If x is positive, we can only take the logarithm of positive numbers, you might recall. Laws of logs, page 60. Log of xy is log x plus log y. Log of a quotient is the difference of the logs, log x minus log y. And log base b of x to the r is r log base b of x. Exponent can come down in front or climb back up. In particular, log base e of x means ln of x, natural log or log natural, log base e. Ln x equals y means the same thing as e to the y equals x. And the cancellation laws, ln of e to the x is x, and e to the ln x is x. Here, x can be any real number. Here, x has to be positive because we can only take a natural log of positive quantities. And among other things, that means ln of e is 1. Okay, change of base formula. Log base b of x, ln x over ln b. We had that in logs in intermediate algebra, perhaps. See examples of that. Okay, what does a log function look like? Well, exponentials look like this, e to the x. If you reflect across the line y equals x, you get the inverse function y equals ln x, looks like so. Okay. Okay, so go back to here. So 5 through 8, they're all functions. They all pass the vertical line test, but is it a one-to-one function? So 5 is not. I can draw a horizontal line which touches 2 points. 6 is one-to-one. Vertical line, horizontal line is drawn anywhere, will only touch at 1 point. 7 is one-to-one. If I draw a horizontal line, it will touch at only 1 point. 8 is not one-to-one. It looks like I can draw a horizontal line maybe like that. It'll touch at 2 points. 9 through 12, well, we have to know something about the graph. Number 9, that looks like a line with a slope of 2 and y-intercept of -3. So roughly it looks like that. So that would be one-to-one. 10, fourth power, okay, it still kind of looks U-shaped. And move it 16 units down from the origin. So it's still U-shaped. So if it's U-shaped, it would not be one-to-one. It would not pass the horizontal line test. Okay, 11 is a variation of the sine. We know sine goes like that. So it's not one-to-one. You can draw a horizontal line which touches at a lot of points. And cube root function is one-to-one. It looks something like that. It doesn't curve up actually. So 12 is one-to-one. Okay, 15, just the definition of a function and its inverse. If f of 6 is 17, then f inverse of 17 is 6. Just reverse this. And b, likewise, if f inverse of 3 is 2, then f of 2 is 3. So no big deal. Okay. 18 and 19. 18. Why is f one-to-one? It passes both the horizontal and vertical line test. What are the domain and range of f inverse? Just give the domain and range of f, and just switch them. Okay. And if it says f inverse of 2, you're saying y is 2, not x is 2. So y is 2. What is the x? That looks like it's 0. And D, estimate the value of f inverse of 0. So y is 0. So you can see why it says estimate. Looks like it's maybe negative 1.7 or something like that for 18. Okay, now 21 to 26, find the inverse of the function. Okay. Finding the inverse of the function. 1.522, f of x is 4x minus 1 over 2x plus 3. Call this y. Switch x and y. Everywhere you see y, put x. Everywhere you see x, put y. And then resolve for y. Multiply both sides by 2y plus 3. So 2xy plus 3x equals 4y minus 1. Then I will try to solve for y. So I'll add 1 to both sides and move the 2xy over here. So it now says 3x plus 1 equals 4y minus 2xy. Factor out the y, and then divide by the factor. So y equals f inverse of x is 3x plus 1 over 4 minus 2x. 24, y equals x squared minus x. X is greater than or equal to half. Why do they say that? This looks like a parabola which opens up, which is not one-to-one. But for x greater than or equal to 1/2, the vertex here is at x equals a half. You can use the formula negative b over 2a, you might recall, for the vertex. Vertex is at x equals negative b over 2a. So negative 1 over 2 times 1 is 1/2. So that means I throw this part out. I only have this portion of the graph. So if I only have this portion of the graph, it is 1 to 1. Okay, switch around x and y. X equals y squared minus y. Okay, to keep going, I have to complete the square. Take half the coefficient of y and square it. Half of negative 1 is negative 1/2. Negative 1/2 squared is 1/4. So I add 1/4 to both sides. Looks like this. So x plus 1/4 equals y minus 1/2 squared. Take the square root of both sides. I only want the positive because I have the right portion here. So square root of x plus 1/4 equals y minus 1/2. So y equals f inverse of x is 1/2 plus radical x plus 1/4. Okay. 26, they give me y equals this. Switch around x and y. X equals 1 minus e to the y over 1 plus e to the negative y. Multiply both sides by 1 plus e to the negative y. X plus x e to negative y equals 1 minus e to negative y. Get all the y's on this side, move the x over. So that'd be 1 minus x on this side. This side will have x e to the negative y plus e to the negative y. Factor out e to the negative y. E to the negative y times 1 plus x. Divide by 1 plus x. E to the negative y. 1 minus x over 1 plus x. Excuse me. Okay. Get rid of the e by taking the natural log of both sides. So ln. So ln and e cancel out. So I have negative y equals ln 1 minus x over 1 plus x. Multiply both sides by negative 1. So y equals f inverse of x is negative ln 1 minus x over 1 plus x. Okay. And this is acceptable to me, but if you apply the negative exponent and put it up here, that's a property of logs. That means you take the reciprocal. So the best answer is ln 1 plus x over 1 minus x. There's one fewer negative symbol there. Okay. 31 asks something about the inverse of radical 1 minus x squared. 31, f of x is radical 1 minus x squared. Find the inverse and how is it related to f. Okay. Okay, so switch around x and y. X equals radical 1 minus y squared. Square both sides. X squared equals 1 minus y squared. Add y squared. X squared plus y squared equals 1, which you might recall as a unit circle. Okay, so the graph we have for f of x equals radical 1 minus x squared is this first quadrant part. Anyway, solve that again for y. Subtract x squared, take the square root. Y equals f inverse of x is square root of 1 minus x squared. Okay, how does that compare with the original? It's the same as the original. So here's a function which is its own inverse. Okay, and it seems reasonable if you reflect across the line y equals x, you get the same graph. Okay, so the inverse of this function is itself. Okay, some problems with logs. Find the log base 5 of 1 over 125. Call it x. Unscramble it. 5 raised to what power? 5 to the x equals 1 over 125. I can write 1 over 125 as 125 to the negative 1. Then I'm going to write this as 5 to a power. This is 5 cubed to the negative 1. The reason why I want to do that is I want this to be 5 to something, and I want this to be 5 to something. 125 happens to be 5 cubed. And then if you have a power and then another power, you multiply them. So 5 to the x equals 5 to the negative 3. So that means x equals negative 3. Okay, ln of 1 over e squared. I can write 1 over e squared as e to the negative 2. And then ln and e cancel out. I just have negative 2. 38, e to the negative ln 2. That negative 1 can climb back up as an exponent. E to the ln 2 to the negative 1. And then e and ln back to back cancel out. 2 to the negative 1 is 1/2. 38b, e to the ln e cubed. Well, just look at this. Ln and e cancel out. So this part is 3. So I have e to the ln 3 and e to the ln cancel out. So I have 3. 40, they want you to write it as a single log. The coefficients can climb up as exponents. So 2 comes up, becomes a c squared. 3 comes up, becomes a d cubed. This is an addition, so I multiply. This is a subtraction, so I divide. So write it as a single log, ln of b c squared over d cubed. Okay, change your base rule. 42a, log base 5 of 10 is simply ln of 10 divided by ln 5. Punch it in a calculator, it's about 1.43, and so on. Okay, quick graph of log base 10 of x plus 5. So logarithm functions generally look like this. They pass through the point 10. This is a translation, a move of 5 to the left. So 1, 0 moves over to negative 4, 0, and I just draw the same graph. And the asymptote used to be the y-axis, which is x equals 0. Now it becomes x equals negative 5. Y equals negative ln x. So I take the graph of ln x, and negative ln x reflects the graph across the x-axis. So if I take this part over here and reflect, it comes down here. And if I take this part and reflect, it comes like so. So the red is the graph of negative ln x. All right, 52a, ln x squared minus 1 equals 3. Exponentiate both sides, put an e. E will cancel the ln. X squared minus 1 equals e cubed. X squared is e cubed plus 1. Take the square root plus or minus. So x is plus or minus the square root of e cubed plus 1. B, e to the 2x minus e to the 3e to the x plus 2 equals 0. Treat this as e to the x squared minus 3e to the x plus 2. So essentially, it's like e to the x becomes your variable. So we have e to the x minus 1, e to the x minus 2 equals 0. By the way, if you multiply this out, FOIL that back out, you get this. So that means e to the x equals 1, or e to the x equals 2. ln. So x is ln of 1, which is 0, or x is ln 2. 54a, the original said ln of ln x equals 1. Exponentiate to knock out that e. E to the 1 is e. So I have ln x equals e. Exponentiate again, put an e here and e here. So x is equal to e to the e power. Okay. B, e to the ax equals c e to the bx, where a and b are not equal. Not sure how that comes into play yet, but we'll see. Okay, get the e's together, divide both sides by e to the bx. This cancels out. So I have e to the ax minus bx equals c. Take the natural log of both sides. Ax minus bx equals ln c. Factor out the x. And divide by a minus b. So x is ln c over a minus b. And that's the reason why it said a is not equal to b. Because if a and b are equal, then this doesn't make any sense. Okay, finally a little bit of trig. Inverse cosine of negative 1, I'll call it theta. Unscramble it. Cosine of theta is negative 1. So cosine of what angle is negative 1? You want the x coordinate to be here. That's 180 degrees. Or we're doing radians, so pi radians. Inverse sine of a half, call it theta. Therefore, sine of theta is a half. Sine of 30 degrees, or pi over 6, is a half from the unit circle. Okay, 65a, inverse cosecant, radical 2, call it theta. Cosecant of theta is radical 2. Take the reciprocal of both sides. Reciprocal of this equals the reciprocal of this. Sine of theta is 1 over radical 2. 1 over radical 2 is radical 2 over 2. Sine of what nice angle is radical 2 over 2, pi over 4. Inverse cotangent of negative radical 3, call it theta. Cotangent of theta is negative radical 3 over 1. Cotangent is cosine over sine. Trick is to divide top and bottom by 2 because it works. So therefore, cosine of theta is negative radical 3 over 2. Sine of theta is a half. Okay, the second quadrant angle that makes that work is 5 pi over 6. Okay, I go half a unit up and I see 5 pi over 6 here. Little bit of review of some right triangle trigonometry. You might recall SOHCAHTOA. Some of you have heard of SOHCAHTOA. If you've never heard of it, what is SOHCAHTOA? So in a right triangle, here's theta. Here's the opposite side, the adjacent side, and the hypotenuse. So means sine of theta is opposite over hypotenuse. Ka, cosine of theta is adjacent over hypotenuse. And TOA, tangent of theta is opposite over adjacent. So we'll see how that comes into play. Okay, quickly, 65b, arc sine of 1, call it theta. Sine of theta is 1. So y coordinate is 1, theta is pi over 2. Okay, 69, find cosine of inverse sine of x. Call this theta. Ultimately, I want to find the cosine of theta. So theta is inverse sine of x. That means the same thing as sine of theta is x, x over 1. So I draw my right triangle. Here's theta, opposite over hypotenuse. Do a little bit of Pythagorean theorem, a squared plus b squared equals c squared. I call that y. X squared plus y squared equals 1. So y equals the square root of 1 minus x squared. So this is radical 1 minus x squared. I want cosine of theta. So cosine of theta is adjacent over hypotenuse, radical 1 minus x squared divided by 1. Final answer is radical 1 minus x squared. 70, find tangent of inverse sine of x. Again, call that theta. So ultimately, I'm trying to find the tangent of theta. Theta is inverse sine of x, which means sine of theta is x over 1. So once again, sine of theta is opposite over hypotenuse. So the adjacent, the same work as here, it's radical 1 minus x squared. And I want tangent of theta. So tangent is opposite over adjacent, x over radical 1 minus x squared. Finally, 72, sine of 2 arc cosine of x. Call this theta. Theta is arc cosine of x. Arc cosine and inverse cosine means the same thing, arc and inverse. So cosine theta is x, x over 1. So ultimately, I'm trying to find sine of 2 theta, which is 2 sine theta cosine theta, an identity from trig. All right, so cosine adjacent over hypotenuse. So algebra is the same as this and this. It's radical 1 minus x squared. So I'm trying to find sine of 2 theta, which is 2 sine theta cosine theta. So 2 sine of theta is opposite over hypotenuse, radical 1 minus x squared divided by 1. And cosine of theta is x over 1. So final answer is 2x radical 1 minus x squared. All right, so that's section 1.5.